Hello everybody. I hope you guys are all doing really well. Welcome to your lesson on periodic trends. Now we are continuing in Unit 4, which is our unit on bonding. We already learned about ions right before we got out of school because of this whole coronavirus craziness, but I'm going to review ions with you really quickly before we dive into our periodic trends. These notes, I've already linked the guided notes on your assignment for the day if you wanted to print them, or you can just take hand notes, and these will go on page 41 of your interactive notebook. This first information you don't have to jot down because you should have your ion notes on page 40 of your notebook, but this is just a reminder about ions. So remember, when we are looking at the structure of an atom, you have your protons and your neutrons in the nucleus, and the negative electrons circle around the nucleus. Now, typically we follow the 8-man rule, so A equals P equals E. The atomic number is equal to the number of protons is equal to the number of electrons, which gives you a neutral atom. Ions are not neutral atoms. They're either missing or gaining a couple electrons. So basically an ion is just an atom with a varying number of electrons. Remember, the electrons are negative. So if an atom were to lose an electron, they would become more positive. And if you gain an electron, you become more negative, which is kind of, remember, counterintuitive, because normally if you're gaining something, it's an addition, but here it's vice versa. So if you're losing an electron, the atom becomes more positive. If you're gaining, you become more negative. Just a reminder also, atoms want to be stable, and they all want to have 8 valence electrons in their outermost shell. Okay, so they want to get to a noble gas configuration. And in that, metals on the left-hand side of the table tend to lose electrons, and then nonmetals tend to gain them. So they'll go whichever way gets them to an 8 or a noble gas outermost shell the easiest way. Okay, so that's a review of your ions. Now let's jump into periodic trends, and these are where your new notes start. So when we talk about periodic trends, we're going to be talking about properties of these elements that we can identify based on their position in the periodic table. So the first thing we're going to be talking about is atomic radius. Now you guys have a bunch of notes in your notebook with periodic tables, and you guys can draw these arrows on any of them. Okay, just choose one of your periodic tables, pull it out. You can pause the video and just choose one where you're going to draw the trends, and you can draw these arrows. So for your atomic radius, you're going to have an arrow at the top going from going to your left, so starting at the right and moving left, and then starting at the top and moving down. So what is your atomic radius? This is just half the distance between the nuclei and the outermost shell, or your ring. Okay. As you move to the left, your atomic radius increases. So those elements that are on the more left-hand side of the table are going to have a larger atomic radius. It also increases as you move down. So those elements that are more to the left and then further down on your periodic table are going to have a larger atomic radius. So if we look at a periodic table, and you guys should have your reference tables and also all the tables in your notes, it doesn't matter which one you look at, take a minute, pause the video, and see if you can figure out what the element would be with the largest radius. So remember, it increases as you move to the left, and it increases as you move down. So take a minute to do that. So your element with the largest radius is francium. Did you get it? Okay, so what does this even look like? How can we visualize this? So this doesn't go down to francium, this just goes to cesium. But this is just showing you your atomic radii as you move across the table. So if we start at helium, helium has a pretty small atomic radii, and as we move to the left, hydrogen's a little bit larger, okay? Starting with, let's look at argon, so our noble gas in period 3. Argon's got a smaller one, and as we move to the left across the table, sodium's atomic radius is larger. But the atomic radius is also increasing as we move down. So hydrogen at the top has a smaller atomic radius, and as you move down that group 1 to cesium, and then ultimately francium below that, they are going to have the largest atomic radii. So now that we've talked about our atomic radii, let's talk about electronegativity. So again, on any of those periodic tables you guys have in your notebooks, you can draw these arrows to show you which way the trend of electronegativity goes on your periodic table. So what is electronegativity anyway? This is the atom's ability to gain an electron. Okay, so remember, electrons are negative. So if we're gaining an electron, we're becoming more negative. It increases as you move to the right, so elements on the right-hand side of the table will be more electronegative. And then it also increases as you move up. So those elements that are going to be in the top right-hand corner are going to be the most electronegative. So what is the most electronegative element? Take a minute. Pause the video and think. What do you think the most electronegative element would be? Is it helium? No, it's not helium. It's actually fluorine. Okay, so why would we think about fluorine? So fluorine is actually in our group 7, so it is a halogen. Remember that your noble gases are stable. They don't need to gain or lose. And also helium is special because it only has 2 valence electrons, and so its outermost shell is already filled, so it's not going to react and not become electronegative the way that fluorine will. Okay, so we're going to look at your group 7 for your electronegativity. So our most electronegative element that is not stable is going to be fluorine because it's the topmost element that's also the top right. Okay, so it increases as you move right and it increases as you move up across the table. Ionization energy. So ionization energy is just the energy required to remove an electron. And again, you guys can draw these arrows, pause the video and draw these arrows on whichever one of your periodic tables you need to. It increases as you move to the right, and it also increases as you move up. So just like your electronegativity trends, your ionization energy is going to increase as you move to the right and up. Now the element that requires the most energy, take a minute, pause the video, see if you can figure it out. It's helium. Yes, it is helium. Okay, so helium can lose an electron, and because of its position in the periodic table, we know that it has the highest ionization energy. Okay, so there's no trick with this one. You are literally just looking at which elements are furthest to the right and furthest up. Stability trends. So let's just talk about some of these trends. We already know where our metals and our nonmetals are in the table. So metals generally contain a positive charge because they tend to lose electrons. Okay, and then our nonmetals generally have a negative charge because they tend to gain electrons. Okay, remember, if you're gaining an electron, if you're gaining that particle that is negative, you become more negative. Okay, so remember I showed you this when we were trying to figure out our ions on that very last day before the coronavirus struck. But those elements in group 1, they tend to lose 1 electron. In group 2, they tend to lose 2. If we go over to group 13 or 3A, they tend to lose 3. And then remember, the carbon group's a little bit funky. Normally they don't really tend to form ions, but if they lose 4, then they become a 4 positive. And then when we move into our nonmetals, they tend to take on electrons. So then we see a more negative charge for those. And then again, our noble gases, they are stable. With the exception of helium. Helium has 2 valence electrons, where the rest of your noble gases have 8. They tend to have no charge. Okay, they don't have any charge because they're stable. They don't need to gain or lose electrons. They are happy. All right, so that is the end of your periodic trend notes. Go back and rewatch the video, take notes as you need to. When you're done and you feel comfortable, go back into your assignment for the day and go ahead and complete your periodic trend checkup. It's going to be a list of, or it's going to be some problems with elements just asking about trends about stability, electronegativity, ionization energy, and just asking which one of these elements is more electronegative based on where its position is in the periodic table.